Right, in question 8 then, we've got two complex numbers. First thing I want us to do is write beta in this form, so z equals a plus bi. Easiest way to do that is we're just going to expand those brackets and then work out what the numbers are. So 4 root 2 cos 5 pi over 8 plus 4 root 2 times sine 5 pi over 8, and that's times I. Right, then to convert it, I just put that in my calculator and find out what it comes out as. So we found here beta equals minus 2.16 to 3 significant figures plus, and then we're going to do the same thing again but with sine. Right, now in part B we want the modulus and argument of alpha star. Right, so the modulus of alpha star, what all we do is we change the sign on the imaginary part, so it's still going to have the same modulus, which is 2. Now for the argument we can imagine our here's alpha. Now when you find alpha star, you same as reflecting in the real axis, we're just changing the imaginary part, so alpha star will be down there, and you can see that the argument is the same but it's below the real axis, so it's negative. So the arg of alpha star will just be negative pi over 8. Right, so for C, it now wants us to find the modulus of alpha times beta. Now for this, the easy way, rather than having to multiply them, is to remember the rule that this is going to be the same as the modulus of alpha times modulus of beta. Now the numbers are already in modulus argument form, so that's going to be 2 times 4 root 2, so it's going to be 8 root 2. Similarly then, for part 2, we want the modulus of alpha divided by beta, so that's the modulus of alpha divided by modulus beta, so that's going to be 2 divided by 4 root 2, which is probably best just put in rationalised form. So that's the same as root 2 over 4 if you multiply top and bottom by root 2. So then the third one is going to be arg of alpha beta. Now this key fact is that's the same as the argument of alpha plus the argument of beta, so it's going to be pi over 8 plus 5 pi over 8, which is 6 pi over 8, or 3/4 pi. And then finally, part 4 wants the argument of alpha divided by beta, and our key fact of that is it's arg alpha minus arg beta, so that's pi over 8 subtract 5 pi over 8, so it's negative 4 pi over 8, or negative a half pi, or pi over 2. Right, the last part I'm just going to do up here, we've got a bit of space, so now it wants us to draw alpha beta and alpha divided by beta on an argand diagram. So let's create our axes. Okay, so it's imaginary. So here we've got the real. We don't actually need to work out what alpha beta are because we've already got the modulus and argument. So the argument of alpha times beta is 3/4 pi. So we know that 90 degrees is pi over 2. So 3/4 pi and 180 is pi is going to be over here. Okay. So it's going to be that way. And it's got an argument of 8√2. It's going to be somewhere over there. And then alpha divided by beta has an argument of minus pi over 2. So that's going to be going directly down the imaginary axis. And we know its modulus is √2/4. So it must just be there.